All right, guys, so we're going to learn about section 4.5, which is in Introduction to Parallel Lines. To do this, we actually introduced this word plane to you guys. A plane is a surface so that if you connect any of the 2 points on that surface, they're connected by a line, and all the points on that line are also on the surface. It sounds more complex than it is. So it's a surface. I'm going to draw you a picture and I'll show you. That if any 2 points on the surface are connected, all the points on the line are also on the plane or on the surface. What I want you to look at this as is a piece of paper. So you guys, that's all a plane is. It's kind of like a piece of paper, okay? And you can have different pieces of paper in different locations. One of them's down low, one of them's up high on your desk, one's on the floor. All it means is if you have 2 points on that piece of paper, call them A and B, okay? If I were to connect those points, every single point on this line is considered also to be on that plane. Now, a plane extends infinitely in all directions, so this plane is larger than what it appears. I wish I knew how to grab the corners of this, but you can actually, maybe this, there you go. So this actually gets bigger in all directions if you needed it to. So it's like a piece of paper that grows infinitely in all directions, but that's, when they're talking about plane, that's what they're talking about. Coplanar are lines that are on the same plane. So A and B are coplanar. Lines, points, segments, rays on the same plane. Okay. You can have intersecting planes. I can get really deep into this. I'm not a good drawer, but it's almost like you have 2 pieces of paper that are like, you know, intersecting each other, kind of like this, cutting through each other, if you would. And so what happens is I can have points that are on this paper that are not on the other paper. We'll call this C. And let's pretend that there's, you know, a line, like almost like a piece of a pencil coming through this. Look at this. I can draw 3-dimensional. That green line, you know, is kind of sticking through that blue plane. But that just means that, you know, CD is not coplanar with AB. It's not on the same plane. So not same plane. Just so we have that. So what we're going to be referencing when we are drawing these lines, and the only reason you guys are learning this is because when we are drawing our pictures from now on, you have to know that they are on the same plane, okay? They're on the same piece of paper. That's just a fancy way of putting this, okay? Let's talk about what a transversal is, okay? So more information. Transversal is a line that intersects 2 coplanar, that means on the same piece of paper, lines in 2 distinct, which just means different, points. For example, let's say I draw 3 lines. We'll call this A, B, and C. Okay, if I were to kind of put points where these lines are intersecting, you can see that only one of the lines are intersecting 2 of the other ones in this picture. So we refer to C as the transversal because C is the one that is hitting both A and B. Okay, C is intersecting at 2 distinct or different points, both line A and line C. So again, we call that the transversal. Okay, and this is going to lead us into naming all different kinds of angles. So when we have a picture that kind of looks like this, so I'm going to draw two kind of options here. So we'll do one kind of like this. I'm going to draw it obscure so they don't look like they're parallel, because you cannot ever assume something in my class. So I'm just going to draw it so they don't look parallel. And then I'll draw another, you know what, I'm just going to be lazy. I'm going to copy this, and I'm going to paste it, and I'm going to flip it or rotate it this way. Okay, so we're going to have two kind of drawings here. This drawing over here, we're going to have line D, E, and F, and over here we will have line G, H, and J. Okay. So I'm going to highlight my transversal in blue. So in this picture, F is my transversal. In this picture, J is my transversal. And again, you can see those are the lines that are intersecting the other lines at two distinct points. So those are my transversals. The other lines, I call them my sandwich bread lines. Okay, I'm gonna highlight those in pink. So here's my sandwich bread lines, and in pink right here. The first thing I want you guys to know about these sandwich lines is if you were to smash these sandwich bread lines together, do you guys see the color that I'm coloring the pink right here? This is called the interior. Now I'll draw it in black. Interior. And so when they refer to the lines, they talk about being on the interior of those lines. And that is what is referred to as the interior. It's the inside of those sandwich bread lines, which means that they refer to this as the exterior. Okay, out here, exterior, and out here is your exterior. Okay, so we have our interior and our exterior. So keep that in mind as we are looking at these types of angles. Okay, so we have our interior and we have our exterior, and the blue line is called your transversal. Okay, we all have that down. Now, hopefully you paused it if you didn't. We are going to be learning about different kinds of lines, angle pair relationships formed by these kinds of lines. So the first type of angle that we have is something called an alternate interior angle. Okay, and I'm going to draw again just some kind of like an obscure picture here. So I have my two sandwich bread lines, and then I'm going to draw kind of a transversal here. And what's so special about a picture like this is it's always going to create these 8 different angles. You can see these, there's 8 angles up there. There's also 8 angles here. I'm going to number them 1, 2, 3, and 4, 5, 6, 7, and 8. So it's creating these 8 angles, and some of these angles have a name to them. That's all this is the definition of a name to them. Alternate just means on opposite side of the transversal. So what that means is one of them is going to be on the left side of the transversal, one of them is going to be on the right side. We already discussed interior. Interior means inside your sandwich bread. Okay, so right here. And an example of your alternate interior angles are going to be angle 4 and angle 6. This is an example of 2 angles that are alternate interior. 4 is on the left side of the transversal, 6 is on the right side of the transversal. They're both on the interior, and one of them is kind of attached to the top of your sandwich and one of them is attached to the bottom of your sandwich. Okay, my crazy algebra teacher actually came in and started drawing Z's all over the board, and so that's how I kind of remember them right here. So if you look at my Z that I'm drawing, 4 and 6 are kind of in the little crooks right here of that Z. And so that's how I always find my alternate interior angles, is I kind of draw my Z. The same thing holds true if you guys actually draw your Z backwards like this. So your 5 and your 3 are also called alternate interior angles. Angle 5 and angle 3 are another example of alternate interior angles. Okay, the second type of angle that we're going to be talking about is alternate exterior angles, and that's exactly like what it sounds like. Opposite side of the transversal. Exterior means on the outside. So my example of this would be angle 1 and angle 7. Okay, and another example of this would be angle 2 and angle 8. Angle 2 and angle 8. Okay, and again, you can see one of them is on the right side of the transversal, one of them is on the left side. One's on the top, piece of your sandwich bread, one's on the bottom piece of your sandwich bread, and they're both on the exterior of your sandwich. Okay, and then the third part of angle that we're going to be talking about is called corresponding angles. And corresponding angles just mean the same location. Okay, corresponding angles just means the same location. And this is what I mean by that. If you take a look at these 4 angles and these 4 angles, I would describe 2 as being in the top right of this circle. The angle that is in the top right of this circle is 6. I would describe 3 as being on the bottom right. I would describe 7 as also being on the bottom right. What it means for same location, so it means on the same side of the transversal, and in the same location of the sandwich bread. So they're both below the sandwich bread, or they're both above the sandwich bread. And my examples for these, again, are angle 2 and angle 6, angle 3 and angle 7, angle 1, which is on the top left, and angle 5, angle 4 on the bottom left, and angle 8. Those are all examples of corresponding angles. Okay, so we have alternate interior, alternate exterior, and corresponding angles.